Bueno, en esta unidad de HCP estamos viendo precisamente lo correspondiente. Es un tema que estuvimos mencionando constantemente, por lo cual pues, no voy a ahondar mucho en él. Está muy sencillo, les invito a que ustedes le echen un ojito, por favor. Y pues bueno, al fin y al cabo aquí nos habla de precisamente el protocolo de HCP, cómo funciona, obviamente DORA, Discover, Offer, Request y Acknowledgement en este caso, que creo que es lo más importante de este módulo, puesto que ya anteriormente habíamos trabajado en ello. Eh, Aquí vienen los videos. Voy a poner ese video que se me hace pues interesante. Lo demás habla acerca de la asignación de una IP estática, que ya anteriormente lo hemos trabajado en Packet Tracer, la asignación dinámica con el protocolo de HCP, que obviamente también ya lo hemos trabajado con el enrutador de, del Packet Tracer, el WRTN 300, que asigna direcciones dinámicamente, que apenas hicimos en clase. Y bueno, aquí en esta imagen pues vemos un servidor de HCP donde nosotros somos los clientes, ¿no? Y quienes obviamente nos dan el servicio, pues el proveedor de servicios de internet, el router que se programa, como apenas lo vimos en clase, un servidor que también puede fungir como de HCP y bueno, también otro servidor aquí que está dando el direccionamiento. Y nuestro router Cisco, bueno, nuestro router de WRTN 300 o el que ustedes tienen en casa, ¿no? Que ya vuelvo a repetir, lo hemos trabajado. Y bueno, algo aquí, volvemos a lo mismo importante, es la configuración de HCP, que habla acerca de DORA, en este caso. Vamos a replicarlo aquí.
Earlier, you learned that IP address assignments can be given out in two ways. Statically, meaning that someone actually sits down and configures the IP address, or dynamically, where the device gets its address from a DHCP server. DHCP means the protocol that is being used to obtain that IP address. DHCP stands for Dynamic Host Configuration Protocol. So how does that protocol work? The protocol describes a set of messages that go between the host wanting an IP address and the DHCP server that gives out the IP address. So basically, what we have is we have a host system that sends out a packet called a DHCP discover. And what this packet is doing is actually looking for a DHCP server. The packet is a broadcast packet, and it contains the MAC address of the device requesting the IP address, and it is destined for any device on the network that's configured to be a DHCP server. What kind of devices can be DHCP servers? Well, typically in a home network, the home router, the wireless router or the wired router, is configured to give out DHCP. In larger environments, often this is a server that would be doing other functions like Microsoft domain controlling, or it might be a Linux server that also doubles as a web server. So basically, the DHCP server can be a number of different types of devices. So when the DHCP discover goes out, since it is a broadcast, any DHCP server attached to the network will hear that. The DHCP server then responds with a DHCP offer. The DHCP offer packet contains an IP address that the host, the individual device, could use if it accepts it. When the host receives the DHCP offer packet from the DHCP server containing the IP address, and here's the IP address that was sent, and the subnet mask, as well as the default gateway address. Once the host receives that, it sends back a DHCP request packet that it will accept the offer. And it will request the IP address that the server had sent it, 192.168.1.15. The device will then take this information and enter it into its IP address settings. And at that time, once the server receives the DHCP request, the server will send back a DHCP acknowledgement that will indicate to the host that the server is placing this IP address into its table associated with the MAC address that was sent from the host. There are two ways to get an IP address on a device. One way is to manually configure it, or statically configure it, as it's called in Microsoft Windows. And the other way to do it is to get it automatically from a device that provides DHCP. In the little network here that we're showing in Packet Tracer, we have 3 PCs attached to a DHCP-enabled router. Basically what this is a very similar device to what you would have at home. If you look here on the device itself, you'll notice that this device has a switch port, an antenna for wireless, and an internet connection. This type of configuration is available on almost every home wireless router. So basically what we're going to do is we're going to go in and we're going to look at how DHCP is configured on this device. Most home devices, home networking devices, have a GUI interface to make it easy to set them up. In the case of this device, you can see that I have some settings that are basic router settings. In this, on this router, we are going to enable DHCP, and as you can see by default, it's normally enabled. And you can see that an IP address has been already assigned to the router interface that faces the LAN. When the automatic configuration is received by the PCs, they're going to see this address as their default gateway. Now, the way that DHCP is configured is a group of addresses are reserved on a particular network to be handed out to hosts, one by one. If you look here at the settings, it will say that the DHCP range will start at 172.16.0.100. So if we save this configuration, and then we go to our PCs and enable each PC to get their IP address via DHCP rather than via the static configuration. So we're going to go to the desktop here, and we're going to look at our IP configuration, and then we're going to change it from the static configuration to getting its IP address via DHCP. And you will notice that immediately the device sent out a request for a DHCP address and received one from the DHCP server. You'll notice from the information that since this is the first PC to be configured for DHCP, it got the first available address. When we look at the other PCs and look at their IP configurations, if we change them over to DHCP, they will also get addresses, but they will not be the same address. It will be the next number up. Since we have our IP addresses set, now we can go out and test our network connectivity. So if I'm on PC 0, I'm going to go ahead and ping one of the other PCs. We know that since I have the address 100, the other two devices have the addresses 101 and 102. So we're going to try pinging both of those computers. And as you can see, we can reach that 101 computer, which is PC1 on our diagram. And then we will attempt to configure, to ping PC2. And you can see we can reach PC2 also. So the information that was on the router configuration for DHCP determined what IP addresses would be assigned to all of the PCs on the network.
Bueno, entonces aquí vemos lo que ya hemos trabajado en clase. Aquí viene el resumen y pues lo que queda es hacer de igual manera el cuestionario, el quiz, igual hacer las preguntas e ir capturando obviamente al final su calificación, por favor. Y aquí terminamos de HCP. Creo que es un tema que hemos trabajado y con estos videos se apoya todavía más.